Now dear student, we are going to discuss question number 2.20, and in this question it is given to you two charge conducting sphere of radius A and B are connected to each other by a wire. What is ratio of electric field at surface of two sphere? So in this question it is given to you, let's suppose we have two sphere. Clear? Let's suppose this is sphere number A, or we can say sphere number 1 having radius A. Let's suppose it is connected with a wire with another sphere, let's suppose this one, and it is having radius B. Clear? Now let's suppose I am assuming initial, let's suppose I am saying charge this is present on this sphere is Q1, and here we have charge this is present Q2. Clear to you? Now, so first our objective in this question is to calculate ratio of electric field. Clear? So ratio of electric field means we can write like this, E1 by E2. Now what is location where we have to find electric field? Electric field at surface of two sphere means we want to find electric field at the surface of these spheres. Clear? So we can directly write formula KQ upon R square. So we can write like this, K Q1 upon A square divided by K Q2 upon B square. Clear to everyone? So we can write like this, Q1 by Q2 and multiply with B square upon A square. Clear? Now we can say, let's suppose we have a sphere that is having radius A, another one is B. It is having some charge. It means we can say this is a spherical conductor. Yes or no? So we can assume it as an isolated conductor initially, but when we connect these two spheres with the wire, we can say charge will flow till we can say both sphere will gain a common potential. Clear? Or you can also write like this, charge Q1, this is written like this, C1 multiply V. Why I am just writing V? Because I connect these two sphere with the wire, and when we connect with the wire, potential on each sphere it becomes same. Clear? Or you can say charge flow stops when potential on both sphere becomes same. Clear? So we can say Q1 equal to C1 multiply V. We can also write like this, Q2, this should be equal to C2 multiply V. Clear? So from here we can say Q1 divided by Q2, it should be equal to C1 by C2. Clear to everyone? Yes or no? So now we can say, if we talk about an isolated sphere, for an isolated sphere we can say this is 4 pi epsilon naught multiply with R. So we can say this is multiplied with A. Clear? We can also write like this, 4 pi epsilon naught B. Clear? So we can say this one and this one cancelled out. Clear? So from here you can say, we can also write like this, Q1 by Q2, this should be equal to A by B. Clear? Yes or no? Now we can put value of Q1 by Q2 in this equation. Clear? So from here we can write like this, this is A by B multiply B square upon A square. This one and this one cancel out, this one is also cancelled out. Clear? So from here we can write like this, this is defined as the ratio of B and A. Clear to everyone? So from here you can see, E1 by E2, this is given by B by A. Clear to everyone? So E1 by E2 ratio we have B by A. Clear? Okay. Now can we find value of E1 by E2 in terms of density? Yes. How? Listen carefully. Actually we know E is written like this, KQ by R square. Clear? Now we can write value of charge in terms of surface charge density. Means we can write like this, K, it is multiplied with sigma 4 pi, this is R square, whatever may be the radius of a sphere. Clear? This is R square, we can say this one and this one cancelled out. Clear? So from here you can say E, it is written like this, sigma 4 pi, and value of K you can write like this, 4 pi epsilon naught. So we can say this is written like sigma upon epsilon naught. Clear? So from here you can say E is written sigma upon epsilon naught. Clear? From here you can also say E is directly proportional to sigma. Clear to everyone? So it means what I want to say, I can say, you can also write like this, sigma 1 by sigma 2, it is equal to B by A. Clear? From here you can say, if we are assuming sigma 1 is a surface charge density of sphere number 1 and sigma 2 is surface charge density of sphere number 2. Clear? So from here you can say, you can directly see sigma is inversely proportional to R. Clear? So Now what we can conclude from this result? You can say, let's suppose we have sharp and the pointed end. So whenever we have sharp or pointed end, we can say the radius of curvature is always less, clear? And whenever we have flatter portion, we can say radius of curvature is very large, clear? So what I am saying to you, we can say sigma is inversely proportional to r, clear? And from for the pointed end, we can say r is very less, so we can say sigma is more. Yes or no? It means we can say at a sharp point we always find a large surface charge density, clear? And if we talk about flatter portions, for the flatter portion you can say r value is very large, so we can say sigma value is less. Clear to you? So like this we can actually say that why charge density of sharp ended point is higher, because it is having a less radius of curvature. So when r is less, we can say sigma is more. Clear to everyone? So this is all about this question. Clear?